Hello everybody. Let us discuss some of the numericals of electrical capacitance of a conductor. Now, the first numerical that we are going to discuss here is an isolated sphere has a capacitance of 50 picofarad. First question is calculate its radius, and the second question is how much charge should be placed on it to raise its potential by 10 raised to the power 4 volt. Now look at the first part. We need to find the radius. Now the formula for capacitance of a spherical capacitor, spherical conductor in fact, is 4 pi epsilon naught r. So the value of C, that is the capacitance, is given. You have to find the value of the radius r. So naturally the value of r will be given by 1 by 4 pi epsilon naught c, because the value of c is 4 pi epsilon naught r. So all the values you know, 1 by 4 pi epsilon naught, then into the value of capacitance is given here, so it can be calculated. The answer comes out to be 45 centimeter. Now look at the second portion where the potential is given 10 raised to the power 4 volt, and you have to find the charge. The value of charge Q is equal to C into V, capacitance into the potential. So the second question can be easily answered. C into V, the capacitance, it is given, V is also given, you multiply them and you get this value, 0.5 microcoulomb. I hope this is very clear to you. And the simple question was this. We move to the next one now. In the next question you see 27 spherical drops of radius 3 millimeter and carrying 10 raised to the power minus 12 coulomb of charge are combined to form a single drop. Find the capacitance and the potential of the bigger drop. So let us see how it can be done. We need to find the potential, and the potential, the formula for potential will be C is equal to Q by V, we write. So V is equal to, V is the potential, V is equal to Q by C, where Q is the charge and C is the capacitance of the bigger drop. So we need to find the capacitance as well as potential of the bigger drop. First of all, let us consider small r and capital R to be the radii of small and bigger drops respectively. Small r for the smaller drops, capital R for the bigger drops. Now volume of the bigger drop, it is made up of 27 small drops. So the volume of bigger drop will be 27 times the volume of the smaller drops. So from this we can find a relation between capital R and small r. The formula for volume of a sphere, since drop is in the shape of sphere, 4 by 3 pi r cube for the bigger drop, and for the smaller drop it is 4 by 3 pi r cube, which is to be multiplied with 27 so that the volume becomes equal. Now if we solve this, the value of capital R will come out to be 3 into small r. The value of small r, small drops, the radius is given as 3 millimeters, so 3 into 3, that is 9 millimeters, that is 9 into 10 raised to the power minus 3 meter. This is the value of the radius of the bigger drop. Now the capacitance of the bigger drop, formula is 4 pi epsilon naught r. The value of r we have calculated here, we'll put the value here. So we finally get the result, 10 raised to the power minus 12, or we can consider it to be 1 picofarad. So now what is left out? We need to find out the potential. The potential, the formula is V is equal to Q upon C. The value of Q is calculated first. For the bigger drop, smaller drop has a charge which has to be multiplied with 27 to get the charge on the bigger drop, because the bigger drop is made up of 27 small drops. So you have the value here of the charge in the bigger drop. So the potential of the bigger drop will be the charge on the bigger drop divided by C, the capacitance of the bigger drop, which we have just calculated. Solve it, we get 27 volt, which is the answer. I hope this is very clear to you. let us see the next question. 8 identical spherical drops, each carrying a charge of 1 nanocoulomb, are at a potential of 900 volt each. All these drops combine together to form a single large drop. Calculate the potential of this large drop. Okay, you assume that no waste of any kind, take the capacitance of the sphere of radius small r as proportional to r. See, you need to understand this. In the question it is given 8 identical spherical drops, and they combine together to form a bigger drop. The smaller drop has a potential given 900 volt each. So what will be the potential of the bigger drop? The charge of the smaller drop is also given to you. Now we know that capacitance of a spherical drop is 1 by 4 pi epsilon naught 4 pi epsilon naught r. Now you need to understand that when the capacitance is 4 pi epsilon naught r, that means it is directly proportional to the radius. We can write it in this form where k is the constant here, 4 pi epsilon naught. Charge on each small drop. The formula in terms of capacitance Q is equal to CV. The value of C is given, V is also given. So we write here the value of C we have written here as KR. So we have the value of charge. Now charge on the large drop, that is 8 times of the charge on the smaller drop. So we multiply it with by 8 and we get this value. Now we know that the volume of the large drop will be the 8 times the volume of the smaller drops, because they combine to form the larger drop. So we write it in this form where capital R is the radius of the larger drop and small r, as we have already considered, the radius of the smaller drops. If you solve them, the value of r will be calculated and it comes out to be 2 into small r. So you need to see, you do it yourself, you will get this value. Now the capacitance of the large drop will be the constant k, which is 4 pi epsilon naught into the radius of the large drop. So radius of the large drop is 2r, we have already calculated, so we have this value. Therefore the potential, we are now going to find what we are asked to find, that is the potential of the larger drop, which is charge on the larger drop that we have already calculated divided by the capacitance of the larger drop, which is 2 kr. So kr cancels out, it is 3600 volts. I hope that this question is very clear to you. We move to the next question. Here n drops of mercury of equal radii are possessing equal charges combine to form a bigger drop. Compare the charge, capacitance and potential of the bigger drop with the corresponding quantities of individual drops. That is, we have to compare charge, capacitance and potential of bigger drop with the small drops. Now first of all, let Q be the charge on each small drop and R is the radius of the small drops. So the capacitance of each small drop, which will be written as 4 pi epsilon naught into R, as we have already derived this relation. So the potential will be V is equal to 1 by 4 pi epsilon naught Q by R. Now if capital R is the radius of the bigger drop, then we have done in the earlier problem also, the volume of the total of all the small drops, n numbers are there, so multiplied by n, so the total volume is equal to the volume of the bigger drop. So we calculate the value of R, which comes out to be n raised to the power 1 by 3 into R. So now the charge on the bigger drop, smaller drop has a charge small q, n number of drops were there, so the bigger drop will have charge n into q. So the first question was asked to find the ratio of their charges, that is q dash upon q, which is equal to n. Now second, the ratio of their capacitance. Capacitance of the bigger drop, as per the formula, we have the value of R, we have calculated, we put it here, so we get this value, where C is 4 pi epsilon naught R, so we have written it C. Now we need to find the value of C dash by C, which is the capacitance of the bigger drop with respect to the smaller drop, so it is n raised to the power 1 by 3. Clear? Now we move to the last part of the question, where the potential of the bigger drop is to be compared with that of the smaller drop. So the formula 1 by 4 pi epsilon naught, q dash is the charge on the bigger drop divided by R. So the value of q dash is nq. We have written value of capital R is also there, so we write here. So here it is 1 and it is 1 by 3. If we take this up, so it is n raised to the power 2 by 3, and this value 1 by 4 pi epsilon naught q by R is the potential of the small drop, so it is V. So we have this relation, so therefore V dash upon V will be written as n raised to the power 2 by 3. So the ratio of the charges, then the ratio of their capacitance, and the ratio of their potential is calculated. I hope this is very clear to you. Any doubt, you can post the doubt. Thank you.